Now, isomerism in coordination compounds. Complexes with the same chemical formula can have a different arrangement of atoms possible around the metal atom. This phenomenon of different possible arrangements for the same molecular formula is called isomerism. Compound having the same molecular formula but different structures. Isomerism have its own classifications like structural isomerism and Streoisomerism. Structural isomerism is basically arrangement of atoms in different positions. Streoisomerism is nothing but spatial arrangement of atoms. Their connections are not different, but their arrangement in space is different. Let's take first structural isomerism. It can be first Solvate isomerism, coordination isomerism, ionization isomerism, and linkage isomerism. So structural isomerism having 4 classes: linkage isomerism, ionization isomerism, coordination isomerism, and solvate isomerism. Let's start with the linkage isomerism. What it is? A coordination compound containing ambidentate ligand that can bind metal through 2 different atoms, like isothiocyanate and isothiocyanate. Like nitro group that can bind to nitrogen as well as to oxygen. So it's a linkage isomerism exhibited by ambidentate ligands. This is a nitro complex, this is oxygen bounded nitro group. So these two are linkage isomerisms. Remember, linkage isomerism is exhibited by ambidentate ligands. Nitro. Now, isothiocyanate, thiocyanate, nitrosoil group through NO or oxygen. Ionization isomerism arises from the exchange of counterion in complex salt with the ligands in secondary shell and primary shell. Counterions become ligand and ligands become counterions. Let's take an example. It's a cobalt ammonia sulfate complex with bromide here. What happens here? Bromide comes inside. Here bromide is ionizable, here sulfate is ionizable. Molecular formula or molecular weight will be the same. Only difference is the atoms or ligands in ionizable part and in non-ionizable part. Here bromide is ionizable, sulfate is non-ionizable. Bromide is non-ionizable, sulfate is ionizable. Sulfate is in coordination sphere, bromide is in coordination sphere. Sulfate will go to solution, bromide here will go into solution. Another example is chlorobromo salts. Here bromide is ionizable, chlorine will remain intact. Chloride will go into solution, bromide will stay with coordination complex. Coordination isomerism, third kind of isomerism. We have discussed so far about 2. It arises from the interchange of ligands between cationic and anionic entities of different metal ions present in a complex. Now, coordination isomerism is a special kind of isomerism. It is exhibited only when 2 different metal atoms complexes are present in cationic and anionic forms. Like here, we have a cobalt complex with cationic charge or positive charge on coordination sphere, and a chromium salt with the same 3 negative charge on coordination sphere. It's equal and opposite. And if we exchange chromium and cobalt position, like cobalt will come to this salt, cyano, chromium will go to the ammonia complex. This is, now it is coordination isomer of this salt. Metal atom have exchanged their positions. Solvate isomerism. Solvate isomers differ whether solvent molecule is directly bound to the metal ion as a ligand or merely present as a free solvent molecules in the crystal lattice. Like here we see, what we see here. Here we having the water bound directly to the coordination sphere or metal atom, and it's a violet in color. A solvent isomer will be when if water is present outside the coordination sphere as a ionizable part. Here we see chromium 5 water molecules, one has gone out as a solvable molecule, and one chloride will come inside as Cl2 only. So its octahedral geometry is maintained. This salt is grey-green in color. So solvent isomerism is exhibited by solvent molecules present in coordination sphere or outside only as a solvated molecules. That's what we see. One chloride goes inside and we having a hydrated, one molecule of water as a hydrated. So these were the 4 examples of isomerisms. They are examples of structural isomerism, depending upon whether different type of ligands presence or there is exchange of metal atoms or presence of solvent molecules inside the coordination sphere or outside the coordination sphere. Now, Streoisomerism. Streoisomers have the same chemical formula and chemical bonds, but they have different spatial arrangements. Their examples are geometrical isomerism, optical isomerism. These are the 2 classifications for stereoisomerism. First, geometrical isomerism. Such isomerism arise in heteroleptic complexes due to the different possible geometrical arrangements of ligands, and these isomers and isomerism is exhibited by both square planar and octahedral complexes. First, let's take an example of MX2L2, which is the square planar heteroleptic complex. Both chlorine is present on one side, both amine group present on the other side. Systematically, if they are present diagonally opposite to each other, MX2L2 case, they are called trans. So only one cis and one trans is possible.